Hello, boys and girls. Mr. McCauley here. I am covering the office today, so I am in the school, but I'm not available to be your teacher today. Today I've set up this presentation on light that I want you to watch, and then I'm going to ask you to answer some questions that I've posted in a document in Google Classroom. I would answer the questions as you go along through the presentation. That's what I would do. Anyways, this is about light. So let's talk about light. Light is a kind of energy, and it travels, usually we think of it as traveling in waves, but Einstein was able to show that sometimes it actually travels like a particle, like a small tiny tennis ball. If it's traveling like that, we sometimes think of it as a photon. I've heard that word sometimes used for light. Light can pass through some things, but not all things. And sometimes it gets reflected off different items as well. And finally, light travels very fast and in a straight line. It doesn't curve around things. So where does light come from? Our major source of light is, of course, the sun. The sun is our major source of light on Earth. But where else does light come from? Here's an example, lots of examples of different sources of light, including this bug that is able to combine chemicals and make a little light like it's a firefly. That kind of process is called chemoluminescence. So let's sort some of these light sources. Some are natural. What I mean by that is you find it in nature. It's not made by humans. And some are artificial, again, which are made by humans. Most of our sources of light, we need to usually plug them in. So there's some kind of electrical energy usually, or battery energy that comes with the light sources that we make. So here's a bunch of those pictures again. Let's see what we think. A computer, is that natural or artificial? Well, you got to plug it in. That's artificial. A neon sign, you got to plug it in. That's artificial. The sun, of course, very natural. A light, we plug it in. Lightning is natural. A flashlight needs batteries. Fire, although you could start fire, it is a natural process in that you don't need to plug it in, let's say. So it's a natural source of light. Let's see what's next. The bug is a natural source of light, and finally the candle as well is like fire. It's a natural source of light. You don't need to plug any of those in. So what about these three items? Are they sources of light? Do they give off light? Do they create light? The moon, water, and a mirror. Does the moon create light? Is that why we see it? Does water create light? Does a mirror create light? And the answer, let's say for a moon, no. The moon is not a source of light. It just reflects the light from the sun. And same with water. Water can reflect light, can reflect the sunlight, but it doesn't make its own light. And same for a mirror. A mirror just reflects the light that's around it. So let's talk about light. Light travels in a straight line. A laser is a very concentrated, powerful source of light. Light is very fast. It goes 300,000 kilometers in 1 second. So what does that mean? That means at this speed, it can go around the world 8 times. Imagine how long it would take you to walk around the world. Light can go around the world 8 times in a single second. And light travels much faster than sound. And the example for that is often we talk about lightning and thunder. Thunder is the sound that lightning makes. So when we have thunder and lightning, they happen at the same time. For example, when the lightning strikes. And let's say we have the yellow of the light, and the blue is supposed to represent the sound. So when that happens, the light travels very quickly. You see that right away, but the sound travels a little slower. You hear that later. Okay, objects can be either transparent, translucent, or opaque. What that means is that talks about what happens to them when they interact with light. So let's take a look at this. Well, how does light travel? Light travels, we know, in a straight line from the source of light, could be the sun or a light bulb, and then when it hits an object, an opaque object, some of the light's absorbed and the rest reflects off. So that's how we see something. If an object is transparent, then what happens is the light will pass right through the object very easily, but a small amount might be reflected, but mostly the light travels right through it. And in a translucent object, some light passes through, but the rest will be reflected. So opaque is something where the light doesn't go through. Transparent is the light does go through. And translucent is somewhere in between where some of the light goes through. Okay, let's talk about that one more time. In transparent, all the light goes through. And an example of that could be some clear glass or some clear plastic. Translucent, some of the light goes through. An example of that could be wax paper, sunglasses, a glass that has a frost on it, and maybe a thin fabric like a thin dress where you could, some light goes through and some won't. Opaque is when no light passes through. And something like wood or metal or a thick piece of paper would be opaque. Shadows. Shadows are places where the light is blocked. If you have a light source like the sun, something opaque like a tree, then behind it you will not have any light. That's where the shadow goes. Now, why do we see things? How do we see things? We see things because light reflects off of the object and into our eyes. There's your homework. Hopefully you can see it. And it bounces and hits you, and you can see the light that's reflected off the homework. Now, there's a part about reflection on a mirror, and it has to do with angles. When the ray of light comes in, we call it the incident ray, not stingray, haha. When the light comes in, it comes in at a specific angle and bounces out at that same angle. The two angles here are the same. The incident ray and the reflected ray should have the same angle. And that makes sense. Like, for example, if you have a tennis ball and you throw it against the wall, you can kind of predict, depending on the angle that the ball hits the wall, how it's going to leave the wall. It's the same kind of idea here. Now, light can only be reflected in straight lines. So, for example, if you had some kind of laser set up with different mirrors, you could calculate and figure out where that light is going to hit based on the way it's reflecting off of a smooth surface. But sometimes surfaces are not very smooth. In a mirror, what we just talked about, the reflections are very predictable. They come in at a certain angle, they go out at the same angle. However, sometimes in life, things are not always so smooth. What if you had some kind of rough surface? If you had a rough surface, the light will come in, but it will hit those bits. It'll hit the surface at different angles. And then the light will, instead of scattering off in straight lines, will go all over the place. We call that diffuse. So it's a diffuse reflection when the light scatters all over the place. Again, if you had a really bumpy surface and you were throwing your tennis ball at that surface, you couldn't really predict exactly which angle the ball was going to bounce off of because you weren't really sure what angle the ball was going to hit the wall at. Okay, again, an example of mirrors people sometimes think about is a periscope, where you've got some mirrors and the light from the boat will bounce off a couple of mirrors and into the observer's eyes. Okay. The other use of mirrors could be in a car headlight, where you've got this rounded mirror or this rounded shape. You've got the light source in the middle, and the light goes all over the place, but the roundness of the mirror focuses the light so the beam of light moves out away from the car. color. Why are things different colors? Well, although white light, we think of it as white, it's not actually a single color. It's made up of a mixture of 7 colors. And those 7 colors are what, of course, we call from the rainbow. And we can demonstrate a rainbow by having light pass through what we call a prism, which is kind of usually some kind of triangular glass structure that's able to split light into different colors. The colors of a rainbow. So here's our little prism splitting the light into different colors, and here are the list of colors that are usually associated, the 7 colors of the rainbow. We have red, orange, yellow, green. There's blue. There's this color indigo, which is kind of a mixture of a blue and a purple. And there's violet, which again we classically would probably think of as purple. And here's that list one more time: red, orange, yellow, green, blue, indigo, and then violet. Okay, so how do we see color? So why is a red book red? A red book is red because when all the light comes in, all the white light, only the red light is reflected off. The other colors are absorbed. Now, let's talk about a very curious property of light, and that is sometimes light waves can bend when they're at the border between 2 different materials. So in this example, when the light's coming in and it's hitting the glass prism, the glass rectangle, it actually bends because the density of the air, the thickness of the air is, air's not very thick. And then when it hits the thickness of the glass, there's a change in the density and the light bends at that angle, at that spot. And this is called refraction, when light bends at the border between 2 different objects. And in this case, it bends again as it's leaving the air as well. Now, because of this refraction, objects sometimes look kind of weird. We'll do an experiment later with a pencil in some water, and we'll notice that it looks like the pencil has bent. You've probably seen this before. And the reason for that is refraction. So here's a summary. Light travels in straight lines. Light moves a lot faster than sound. The things we see things because they are reflected light into our eyes. And shadows are formed when light is blocked by an opaque object. That's it. Anyways, hope you've taken some notes, and I will talk to you later.